Hello everyone, welcome back. In topic 4, we will look into the types of graph. My name is Sumarni Abu Bakar and I will guide you to understand and to study about type of graph. Content of this presentation, I will present you the examples of several graph. Includes connected graph, simple graph, pseudograph, tree graph, cycle, wheel and cube graph, bipartite graph, complete graph, Eulerian graph, and also Hamiltonian graph. A connected graph is a graph in the sense of a topological space. There is a path from any point to any other points in the graph. A graph that is not connected is said to be disconnected. Here are examples of connected graph. The first graph is called triangle graph. Second graph is also another connected graph with 4 vertices. The third graph is another connected graph with 5 vertices, and so on. If you look at this connected graph, we can have a path from one point or from one node to any other node in the graph. As for this connected graph here, you can see you can have subgraph of this triangle graph, another subgraph of this particular connected graph, and another graph. With these 3 graphs as a whole, it's create a disconnected graph. There is no path, for example, from vertex 4 to vertex 12, or vertex 14 to vertex 3, or vertex 9 to vertex 14. So as a whole, this graph is called disconnected graph. The first type of graph is called simple graph. Simple graph is also known as a street graph. It is unweighted, undirected graph containing no graph loops or multiple edges. So in a simple graph, it is a connected graph with no loops or multiple edges. The second one is example of non-simple graph, and the third one is also non-simple graph, simply because the last 2 graphs involve multiple edges and loops. Another simple graph here, you can look into this example of road network. So this is one example of simple graph, which is a connected graph, and the other one is also a simple graph, but in this case it is not connected or disconnected graph. Pseudograph. A pseudograph is a non-simple graph in which both self-loops and multiple edges are permitted. In the pseudograph, whether it is directed or undirected, it must involve both loops and multiple edges. Tree graph. A tree graph is an undirected graph in which any 2 vertices are connected by exactly one path. A tree is a connected graph that has no cycle. The main property of a tree graph is that the graph must be connected and the graph must have no cycle. This is one example of a tree graph. Another example of a tree graph. The first graph is a graph with 4 vertices, while the second graph is graph with 3 vertices. The second graph is also known as a line graph. From those 3 graphs, you can see that one point or one node is connected only exactly by one path to another node in the tree graph. Cycle graph. A cycle graph or circular graph is a graph that consists of a single cycle, or in other words, some number of vertices, at least 3, connected in a closed chain. We denote the cycle graph on n vertices by Cn. Here we have 3 examples of a cycle graph. The first graph from the left is C with 3 vertices. The graph in the middle is denoted as C with 4 vertices, while the graph from the right is called C with 5 vertices. Wheel graph. A wheel graph is a graph formed by connecting a single universal vertex to all vertices of a cycle. A wheel graph with n vertices can also be defined as the one skeleton of an n-1 gonal pyramid. We have three examples of wheel graph here. The first graph from the left is a wheel tree. We have one universal vertex in the center of the wheel. The difference between cycle graph and the wheel graph is that in cycle graph, we do not have the universal vertex in the center of the cycle. So we have another example of wheel graph here. In the middle is a graph with 5 vertices, and this is known as wheel 4, and this is wheel 5. Complete bipartite and cube graph. Before I can introduce you complete bipartite and cube graph, you need to know a type of graph that is called bipartite graph. Bipartite graph is a graph whereby we can separate all the vertices in the graph into two sets, and there is a line or there is an edge connecting one vertex in one set to another vertex in another set. There is no edge connecting the same vertex in the same set, or there is no edge connecting one vertex and another vertex in the same set. For example, if you have two vertex in one set, another two vertex in another set, let's say I colored the first set A as red color, and for the set B, let's say it's remained as white vertices, and there is an edge connecting the first vertex in set A to another vertex in set B, like this one. Okay, another vertex in set A to another vertex in set B. So this kind of graph can be considered as bipartite graph. From this bipartite graph, you can see that there is no edge connecting the vertices in the same set. There is no edge connecting the vertices in the same set. From the bipartite graph, then only you can understand the complete bipartite graph. Complete bipartite graph is a bipartite graph whereby all the vertex in set A is connected. The vertex in set A is connected to all other vertices in another set. We must make sure that all vertices in set A is connected to all vertices in another vertex. Or a complete bipartite graph is explained as a bipartite graph in which each vertex in set A is joined to each vertex in set B. Okay, example of complete bipartite graph here is the one from the left. This graph is complete bipartite graph because this can be drawn as two set of vertices. The first set is labeled as A, second set is labeled as B. The vertex in set A is considered the black vertices. The black vertices in set A, while the white vertices in set B. Okay, the black vertices here is connected to all three white vertices. So you can draw this connected to all the white vertices in set B. K13 is the notation used to denote the complete bipartite graph with 4 vertices, one in set A and another in set B. This is one way you can form or you can draw the complete bipartite using set A and set B. Another example of complete bipartite graph is K23, meaning that 2 vertices in set A and 3 vertices in set B. K33 means 3 vertices in set A and 3 vertices in set B. While K43 is 4 vertices in set A and 3 vertices in set B. All vertices in one set must connected to all vertices in another set. One particular complete bipartite graph that we want to let you know here is called cube graph. So this is example of cube graph. The notation used here is Q3. Three here is referring to the degree for each of the vertex. So degree of the black one is equals to 3, degree of the white one is equals to 3. So we denote the cube graph here as Q3. Remember, all the degree of the vertices in the cube graph is regular graph. A graph in which each vertex has the same degree is called regular graph. If each vertex has degree r, the graph is called regular of degree r or r regular. One particular example of regular graph is a graph with 4 vertices. This graph, one vertex is connected to all other vertices in this graph. Okay. The second point here, the second node here is also connected to all other vertices in the graph. The third vertex here is also connected to all other vertices in the graph. Finally, you will get this kind of graph. This graph is called regular graph because the degree for each of the nodes or vertex here is equal. In this case, the degree is equals to 3. This graph can be denoted as K with 4 vertices, or it also known as 3 regular. Why it is 3? Because the degree for each of the vertex in the regular graph is equals to 3. Another example of regular graph is a cubic graph called Peterson graph. This is example of Peterson graph, and this Peterson graph is also known as 3 regular. Why? Simply because the degree of vertex is equals to 3. All the degree of the vertices is equals to 3. Bipartite graph. A bipartite graph, also known as pi graph, is a graph whose vertices can be divided into 2 disjoint and independent sets, and such that every edge connects a vertex into one in. This is example of a bipartite graph, and in bipartite graph we can also use colors to color the vertices so that there are 2 colors used to denote vertex in one set and to denote another vertex in another set. Complete graph. A simple graph in which each pair of distinct vertices are adjacent is called complete graph. We denote the complete graph with n vertices by kn. So this is the K4, which is example of complete graph with 4 vertices. And from the complete graph, you can see the degree for each of the node is equal. This is also called 3 regular. Why it is equals to 3? Simply to denote that the degree of all vertices here is equals to 3. A complete graph is also known as regular graph. Eulerian graph. A connected graph in which all of the vertices are even degree is called Eulerian graph. Example of Eulerian graph here is as follows. The degree of vertex here, A is equals to 2, B is equals to 2, C is equals to 4, degree of E is equals to 2, degree of D is equals to 2. All that the degree of all the vertices in this graph are even degree. Therefore, the graph is called Eulerian graph. Hamiltonian graph. If there exists a closed walk in the connected graph that visits every vertex of the graph exactly once, except starting vertex, without repeating the edges, then such a graph is called a Hamiltonian graph. Example of Hamiltonian graph here is from the left. You can see this is a connected graph with 4 vertices. And if I label the graph as A, B, C, D, you can find a path that connect vertex A to vertex B, from vertex B to vertex C to vertex D. And if you proceed, you can connect vertex D to vertex A, so that you visit vertex A twice. So in this case, this graph is called Hamiltonian graph. Similarly, you can have another example of Hamiltonian graph, that is from the right one. If the label of vertex is as A, B, C, and D, you can find a path that connect all the vertices. Means you can visit all the vertices A, B, C, and D one time. A can connect to B through this path, B can connect to C through this path, and C can connect to D through this path. Or you can connect A to B. Instead of B to C, you can visit D first, B to D, and D to C. Thank you very much for joining us. Hope that you have some knowledge on types of graph. See you again in the next topic.